So this is about the data analysis, and so you're going to be with your, let's see, this is it, right? Yeah, okay. So you're going to be doing a pre-lab, or you've done it already. You're going to read this, you're going to paraphrase this a little bit, then you're going to write up a little procedure, and we're going to exploit this business that if we know distances and we know times, we can get speed. And we're going to play with a spark tape for real this time. So we'll go over it more in class, but at the end of the day, you're going to have a spark tape with about 100 points, and you're asked to you're going to measure, you're going to label them 1, 2, 3 up to 25, and then you don't even need to put a time in there just yet. You're going to write down a position, and you're going to do that at either end of the tape, as close as you can get to the end of the tape. Okay, so this, I guess, this video will be called Intro to Data Analysis. So you will be able to see this template here. It's in the module for the lab. You can download it. And it's going to look, I have some numbers in here, and you see I just did one over it. You'll see it in the lab manual. Of course, we're going to be, it says in the manual, we're going to be setting this to 33. We'll see. So, one of the first things we want to do, though, is we need to take this, and we're going to copy it, and we'll give it over here to make some room, and we can paste it. So, as usual, we're gonna do a fit. We did this in the graphing exercise. Slope, y-intercept. Let's see. It's the sum of the res squared. We don't need to bother with the sum of the residuals because we know that we want res squared. And you see I already did this for you. And so this is, we will have that data, just the dot number and the x position written in your logbook, and then you're going to open this file and you're going to write down your data. Now, let's give me a sec to look this over. I'm going to pause this. We'll restart the recording. Yeah, I don't understand why he has this here. On top of which, this is even the wrong symbol. This is fractional error, and we don't use it. But in any case, we always write down a plus minus. And interestingly, he doesn't have a column for this. Okay, I'm surprised by this. And yeah, I don't know what the heck's going on here. Okay. Measurement errors. Yeah, so there's something going on there. But because we're going to graph, And also we're going to use the tape measure. We're going to use the 0 of we're going to whatever dot 1 is, or dot 0 if you like, we're going to put the 0 of the tape measure, and that point has no error. Okay, so we could calculate a set of yeah, there's a different way to do this, huh? But we'll just go with the manual. They want you to graph the x, the time, and the position. So we're not getting into calculating the v. Well, we'll get the v. Now, you may have learned in class that the slope of the xt graph is speed or velocity. Yeah, I see where I have a video of it's for 1560, all about graphing and such, but it's an hour and some odd long. All right, let's stick to the task at hand. So you type in all your time. Oh yeah, how do we get this? Good. So whatever we happen to set this at, I think he's saying 33. And then this here, I'll zoom in for you. View, zoom to selection. So this is just a number you type in. This is the inverse of it, 1 over. So that's the interval, the time, the delta t for each one of the difference between the dots in time. And so that means that if we define dot 0 at time 0, then the next dot is at 1 time interval. So you see what I do? I multiply the dot number by the time interval, and notice I've got the dollar signs because I wanted to use the same one each time. And then I can just fill it in with the fill handle, and that's the time at each one of them. There are my measurements. Well, yes, centimeters, so maybe plus or minus 0.1 is a little optimistic. We can make it 0.2, whatever you happen to decide. Remember, you estimate this, and then in this case, we can use the same one each time. Okay, so as always, what happened to everything? Oh, no, that was weird. So now we have a time, we have a position, and we can insert a graph. Want a scatter plot without connecting the dots. And so one thing we want to do, we want to add the error bars. I'm going a little fast because we've done this before. So I double click it. I get this. Now we'll make believe we have a Mac. So we hit format up at the top. Format the X error bars, this little bar here, and we set them to a fixed value of 0. And in our case, for the Y error bars, we can actually do the same thing, although the dot at 0 is actually doesn't have an error bar, so I wonder about that. I gotta think that one through. So now I want to format, because we set it exactly on the 0 line, that's why. And now we'll do a fixed value of 0.02, but of course, we do that, you're not even going to be able to see the error bars. But what we could do then is to format the series and we go to marker options, and we can't adjust size till we say built-in. Excuse me. And then we can make them smaller. And now we can sort of see the error bars. They're really small. Okay. So now we know. Once again, let's see. We can kind of guess at the slope. So it's 3 and 12. So 4. No, it's about 40. Let's see. We'll try 40. And the y-intercept is supposed to equal to 0. So we say that equals to the slope, and we need the dollar sign, so we can use the F4 key. And, well, let me stop it. Let me zoom back in for you. Right. So equals to the slope. We need the dollar signs, so you can use F4. And that's times the x-coordinate, which is the time. Excuse me. Plus the y-intercept. And then we need the dollar signs again, because we want it to be the same each time. And so we use our fill handle. And we fill it all in. Oops, so now we want to format this because it's too messy looking. Number, and yeah, we'll stick with 2. So we got it pretty close. And, we don't even need residuals anymore. We're just going to do ghost. Well, okay, let's keep them. They're easier conceptually. So remember, residual is data minus the fit equals the data minus the fit, F5, in this case, F5 minus H5. And then we can just go right down the line. And there's our residuals, so we can see right away the dots are all going to be below the fit line. We haven't put it up there yet. And then we say equals to this guy squared. Fill that in. And then we say this equal to the sum of all them guys. So hot outside. Been inside all day and just not doing a whole lot. Okay, now we got the sum. And then we can use our solver. And so we tell it we want to minimize the sum of the residuals. And we want to vary the slope and the y-intercept. And make, we want to let them go negative if possible. And yeah, I don't have the line. It could be bad that I haven't put the fit line on there. It's probably a good idea to, notice with the good fit, these all just kind of disappear. It's probably a better idea to put the fit line before I do anything else. But let's add some decimal places so we can, they're tiny, so you can see how this is a pretty great technique. There's very little in the way of error bars, and the fit's awfully good. View 100%. And let's see, the y-intercept's not quite 0. So that kind of means we this data has some kind of error in it. Okay. So let's see, select data, and want to add, and this is the fit, and then the y, the x values are the times, and the y values are the fit itself, the fit values. Now, it could be that I actually made this as artificial data that I generated, so you'll forgive me for that, because it fits just too good. Okay, then we need to format the fit series. And now we want to have a solid line. And like I say, I like red. Doesn't have to be. And we're going to make it very thin. And we want to get rid of the marker. None. And there it is. So that fit looks okay. So what happens is now this is our velocity. And let's insert. I like having some space here. So, well, we'll deal with that another time. So this slope is our speed in centimeters per second. Oops. The y-intercept is centimeters, don't forget. Oops, come on. Okay. Alright, then these numbers, we can turn them into numbers. And so 33.1, we're going to round that off. Now, you're going to get another set of dots there, right? So let's just, for the sake of argument, say this one now ends up being 32.99 because and it slowed down slightly. Oh. And okay, wait, let me finish one thought at a time. Now, what I want you guys to do. Let's see. So we put both sets on the same graph. You know, they're going to lie right on top of each other. So I think we need to make two graphs because it won't be a good data presentation. So in this case, before we go any further, we need to add a chart element. And let's put a chart title. And this is, let's say, left side of tape. And then we know it belongs to over here. And then you'll do all the data processing again, do a fit again. And let's say you got this, huh? So the manual says they want us to do this fractional difference, which is pretty standard. It's the difference between the two values divided by the average of the two values. And let's see, snipping tool. And I'm just bringing this. I'm going to get this and paste it here. So, I don't need to put this somewhere, but let's see the frac difference. So this is going to be equal to, and I'm going to use parentheses so that, because if I don't, I'll confuse Excel. So this one, V1, minus v2 close parentheses divided by, and I'm going to open parentheses, and I'm going to open it twice. So first, I'm going to get the sum, this one plus that one. Then I'm going to divide it by 2. And then that quantity I'm going to divide into the difference. So that's the other parentheses. And that is, in this case, pretty darn good. I mean, we can now say percent difference. And then we just say that this equals this guy times 100. So 0.5% difference, you see there. So we should convert both of these to numbers. There we go. And they need a few more decimal places, especially this one. So it's entirely possible that you'll get something like that. These air tracks, we're going to see how good they are. But it turns out, I believe that the friction that counts is the air friction of the sled, like a car pushing through the air. So if we put that 32.5, okay, so now we got a 1.7% difference. But so this is a measure of how good the track represents a frictionless surface. Oh, and oh, by the way, we don't actually need these because we assume that they're the same, right? So here what we do is, oh, and I see another mistake. What goes on here? Dot number 0, because we need it to match the other table. So watch what I'm doing. See, I type 0, 1, 2. So I select those, and then the fill handle, I've given it a pattern, and it copied the pattern, see? So you can rewind that and look that over. So once again, this equals dot number times the interval here, and we need the dollar signs. And then now we've got, once again, our times. And I'm going to make that a number. There we go. And okay, so let's see. There is the, yep, calculate the fractional difference. Right, why do you think it's changing? I already gave you an idea. Oh, another reason could be that it didn't get it completely level. Okay, that forces. Well, Aristotle's, that exactly, as far as I know, his idea was to that things had natural motions. But I guess nothing had a natural motion of continuing. What Galileo did is he made these tracks. He had these artisans make these wooden tracks for him, which I've been to Florence and have actually seen them. Okay, let's think. We're not going to make a paper graph. So let's see. Are your points lying? You can, after you make the graph and the fit, you can answer this question. You're just not going to make a paper graph. That's all. And let's see. Select. Right. That's nominally what you're going to do. You're going to write them down in your logbook, but then you're going to use Excel. Okay, great. So that's good for the data analysis. So I'm going to stop this. Oh, there's the time. All right, so it's the third time I'm going to try recording this video. And I'm just tacking it on the end of what you've already been watching. So the playlist you're going to see won't have this anymore. These 4 videos are kind of a repeat of, in detail, of how to take XT data and get the velocity. So I hadn't planned on making this video so detailed, so I put these in, and then I started making this video, and I went all the way through. So these ones here, you shouldn't even need them, but they're there just to be helpful.